Okay, so we had a question about what chemical shifts need to be known for the final, and the answer is on page 120. It gives a list. 120 in the lab manual. So that page is really a sort of one-page summary. If I were preparing a one-page cheat sheet for the exam on the NMR and IR spectroscopy, that would be what I would put on it. So that's what that page is for. I'd also like to mention that we have so you'll have a table, but it will have some numbers missing from it. Are there any other questions people would like to ask? Okay. Yes.
I have a question. So I was trying to go over like lab safety stuff, but I realized that the PowerPoint that was on Moodle, it's not open anymore. Like it was like a lab course for the lab safety, and it's no longer accessible.
Okay, I will make sure that's available
Okay.
again, so you can review it if you need to.
Yeah.
There are usually just one or two simple questions on safety. It's not too challenging.
Would there be anything on like labeling chemicals?
Um,
Storage?
Yes, there might be just one question, something like that, but not a lot. A lot of the questions are likely to be just fairly common sense questions. I won't ask you, you know, what does pyrophoric mean, or what's a vesicant, or something too obscure. It'll be fairly straightforward.
Okay.
So, as long as you know common lab practice. So, because it is an exam. So, okay. All right, good. So what I'd like to do then is go through the experiments one by one. Start at the beginning and end at the end, hopefully. And if you turn to page 116 in your lab manual, you can kind of follow along. Page 116. So, the first one, Sasha already asked about safety procedures for the lab, and I said very basic information. I will make sure that PowerPoint is available again. I didn't realize it had become unavailable. So, 12 principles of green chemistry. If I ask about that, it's going to be very general. But atom economy and E factor are things that I routinely ask. Pretty much every year I'll ask one or both of those. So please make sure you know atom economy. And E factor. So if you turn actually to, in the beginning, to page 23, you'll see well, I have definitions of those terms and a bunch of other things. So if you're the sort of person who doesn't remember weird words like aspirator and atom economy, etc., condensate ring, you might want to review those words there on page 23 to 24. So atom economy is given here as you are allowed to use a calculator for this. However, since I tend to do most things using mental arithmetic, I like to pick substances at least so that the sum of them, all the reactants, comes to a round number. So for E factor, now this one, let me say, for, oh, and I should have said, this is times 100%. Atom economy is usually done as a percentage, whereas E factor is not. E factor is always going to be 1 or greater, whereas atom economy is always going to be less than 100%. Or it could be equal to 100%. Really what E factor is the mass of the waste divided by the mass of the product. Actually, you can have an E factor less than 1, thinking about it, sorry. But usually it's more than 1 in most reactions. So the thing is, we don't normally weigh the waste directly. What we weigh is what we put in and then the product that we got out. And if you think about it, if you put in 100 grams and you get 10 grams of product out, then the waste must be 100 minus 10, so it's 90 grams waste. All right. Are there any questions on those? All right. So there's a bunch, back to page 116 in your lab manual, a bunch of terms which are also, it says, describe or explain terms from the lab manual glossary. So words like precipitate, boiling, density, etc. What's a solution, a solute, all these different things. I don't plan to drag those out. You either know them or you don't, but like I said, review the glossary and you'll be fine. So how to perform common laboratory procedures such as reflux, recrystallization, filtration, use of rotary evaporator, melting point, TLC, GC, IR, and NMR. You haven't actually run an NMR spectrum yourself yet. Once we get our new NMR machine, which should be early in the spring semester, then you'll actually be able to run these yourself. But you have used the IR, you have used the GC, you've at least seen how the rotary evaporator works. You may have to draw some of these things. It's common for me to ask, do a drawing of a GC machine, do a drawing of a rotary evaporator, do a drawing of a distillation apparatus, something like that. In the case of a complex piece of equipment, I'm looking more at a schematic, so I don't want a lifelike drawing of what the GC oven looks like from the outside. I want a schematic showing the injector, the coil, and then the detector, something like that. Basically what's in the lab manual for those things. Okay. Calculate a percent yield using moles. That's something you learned in Gen Chem, and I'm willing to bet that if I give a simple question on the test, half of you will get it wrong. So, what?
Oh, no, someone asked how you calculate that.
How do you calculate that? Using moles? Okay. I'm glad you've got your friend to ask that for us. Yeah. So, percent yield. Actually, of course, there's a page in the lab manual for that. Page. Where is it? Yeah, page 18 to 19. So the theoretical yield is based on moles. Let me tell you what the standard mistake is. Let's say I start with 2 grams of water and I burn it in air and I get 1 gram of, take 2 grams of hydrogen, I burn it in air and I get 1 gram of water. What's the percent yield? A lot of people would say 50% because you started with 2 grams and you got 1 gram back. But if you burn 2 grams of hydrogen in air, 2 grams is 1 mole. How many moles of H2O are you going to get from that? Sorry? If you start with 1 mole of H2, how many moles of H2O are you going to get from it? If you start with 1 mole of H2, how many moles of H2O will you get from that? 1, right. So if you burn 2 grams of hydrogen in air, how many grams of H2O will you get from it?
Oh, can you repeat that?
If you start with 2 grams,
2 grams is 1 mole? 2 grams of H2 is the same as 1 mole, right?
yes.
So then you'll get 1 mole of H2O.
And what's the mass of 1 mole of H2O?
18.
18. So you burn 2 grams, you get 18 grams back. So if you only got 1 gram of water, you got a lot less than 50% yield. You got 1 over 18. All right? So